welcome all of you to our live session. So you do well to just wait for 1 or 2 minutes. We will start solving this interesting question that is under the topic empirical and molecular formula. So stay tuned. In 1 or 2 minutes, we will start solving this question live on this live stream. So in the next 1 minute, we'll start the live session, and it will be very interesting to see how this topic, empirical and molecular formula, will be dissected in this. Do not to forget to subscribe to our YouTube channel and follow us on our Facebook page for this and more videos. So without wasting much of our time, we will now go live and answer this interesting question. So the question that we have reads, a white powder is analyzed and found to contain 43.67% of sulfur and 56.36% of oxygen by mass. So we have been asked that the compound has a molar mass of 283.88 grams per mole. What is the compound's empirical and molecular formula? So there are steps that one needs to do of the mass of the elements involved. So we are saying step 1, we are going to make the ratio of mass. Now, the elements involved, we have phosphorus and oxygen. So according to what we have here, we have the ratios by mass of 43.64 grams and 56.36 grams. We have just converted the percentages into grams, knowing that whatever sample they analyze, its totality is 100%. So the percentages becomes the composition of the grams of each element that was analyzed in that sample. After you do this, you need to convert these grams to have the mole ratios, and that is what is step 2. So step 2, it is to ratio. Now the mole ratio, it is basically calculated by saying number of moles is equal to the mass divided by relative molecular mass. So we are saying the mass for phosphorus is 43.64 grams. Then the relative molecular mass for phosphorus is 30.99 grams per mole. So we have 30.99 grams per mole. Then we come to oxygen, we have 56.36 grams. We are dividing it with the atomic mass of oxygen, which is 15.99. So 15.99 grams per mole. So here we want to find, in terms of the number of moles, what are the molar ratios of. Now let's divide 43.64, dividing it with 30.99. We are getting the answer of 1.4. So this is the number of moles for phosphorus. Then we go to the next one, which is 56.36 divided by 15.99. It is giving us the 3.5 moles. Now, after you have these two moles, we are now ready to go to the next stage. And the next stage now is to divide the moles with the smallest number of moles. So we are going to step 3, which is basically divide the smallest. So when dividing with the smallest, we have 1.4 and 3.5. So we want now to look at which one is the smallest. You would agree with me that 1.4 is the smallest, so we are saying 1.4 divided by 1.4. Then this side will be 3.5 divided by 1.4. So here, when you simplify the two, we'll get 1. And this other side, 3. We are getting the answer of 2.5. Now, when you have this answer of 2.5, so we are saying 1 to 2.5. This is the mole ratio between sulfur and oxygen. So 1 atom of sulfur is using 2.5 atoms of oxygen. Now, when you have, or you have reached this stage, you simply now have to find a multiplying factor that can help you to have this as the whole number. So let's clear the first part here so that we see what we mean. So we are saying we are now going to find the multiplying factor that can help us to have this 2.5 as a whole number. So the best factor we can multiply with is 2. So for us here and oxygen, if we multiply 1 by 2, we are getting 2. If we multiply 2.5 by 2, we are getting 5. So now that we have these all numbers, then it simply means our empirical formula 2, then O5. So this becomes the empirical formula of this question that we have. So now that we have the empirical formula, we can now look at how to find the molecular formula and see the steps that you need to take to come up with the molecular formula. You do well to like the video, comment on it if there is any question that you need to be clarified on as we are doing this video presentation. So straight away, let's see what you need to do when it comes to the molecular formula now. So we have managed to see the steps for the empirical formula. Let's now see what you need to do for the molecular formula. So for you to find the molecular formula, you simply need to say X multiplied by the molar mass, of the empirical formula is equal to the molar mass, of the molecular formula. So we are saying X multiplied by the molecular formula of the empirical formula. So the empirical formula that we have is this one. We need to get now what is the molecular formula of this empirical formula. So I'll get it here and see how we find the molecular mass, the molecular mass of this empirical formula. So we are saying we have oxygen, we have 5 atoms of it, then the relative atomic mass is 15.99. Then we have phosphorus, we have 2 times 30.97. So let's say 5 multiplied by 15.99, it is giving us 79.95. Then 2 multiplied by 30.97, it is giving us 61.94. So we have to get a sum of these two, that is 61.94 plus 79.95. It is giving us 141.89. So this 141.89 grams per mole, this is the molar mass, the mixture of the empirical formula. So we now have the mixture of the empirical formula there. So we go back to this expression that we said, X multiplied by the molar mass of the empirical formula is equal to the molar mass of the molecular formula. So we'll put this number here, 141.89 should be equal to the molar mass of the molecular formula we have been given there is 283.88. So we want the value of X, which is the multiplying factor. So we'll divide both sides by 141.89, 141.89. So these, they'll simplify. We have X is equal to 88 divided by 141.89. It is giving us 2 as the factor that has been multiplied or that has affected the molar mass of the empirical formula to come up with the molar mass of the molecular formula. So this simply means the empirical formula that we have is P2O5. So this should be multiplied by 2 to get the molecular formula. So the molecular formula will be equal to P4O10. So this becomes the molecular formula when you have been given this question. So you have seen the steps that we have done here. We have first converted the percentages that we had into the mass. Then after converting the percentages into the mass, we found the number of moles of each element that has been given in the compound that was analyzed. Thereafter, after finding the number of moles, we found the smallest number of moles and divided it the number of moles we found. And then after we found the numbers, that is the ratios, we multiplied those ratios so that we can get the whole number, and that made us to have P2O5. Thereafter, we used this relationship where we are saying X, open bracket, molar mass of the empirical formula is equal to molar mass of the molecular formula. And we have found that the value of X is 2. So this simply means the molecular formula is P4O10. Thank you so much for joining us in this live presentation, and you are yet to experience more live presentations from Zuluba Consultants. Until next time, when we announce once again that we'll have a live presentation, it is bye-bye from us.